So this is the data in our products table, and the query that we have just run, it makes sure that whenever we are trying to find some data, then it will do the linear scanning even if the ID has a index already. Products has a primary key, right? And I will get to know regarding this when I'll do explain. I mean, show will be used in then the MySQL. Over here it's explain. Okay. So over here, okay, right now it's doing the index scan, but it's not, we don't have to do the scanning because it's only 5 data in the system. It depends on the query planning. That's why during the query planning, the timing is more in the query planning rather than the execution time, right?
Yes.
So what we, okay, just give me 1 second. Fake call. Cool. So where were we? So we know the index is being used, right? Not the linear scanning is done. Index is being used right now. But if we try to do the same thing, but with instead of ID, let's say that we use name, where name equals to cake. We don't have price over here. We should have a price as well. Over here is sequential scan, right? SEQ means sequential. Then we are trying to filter out by comparing the names. Okay. And this is the data that removed by filter. We removed the 4 rows, and then we got to know, okay, the one cake is there. So that's the data that it is sending to us. But right now, okay, price is also there, right? So instead of taking cake, we can also use the price as well, where the price cost both will be numeric instead of the string. Price equals to, let's say, 100. Okay, there are 2, let's say 750. And over here also sequential scan, right? But with the case of the ID, it was taking the primary key index for the scanning. Right now the data is way too small, so we are not seeing any change. So the first thing that we have to do is to create data, right? So one way that we can do this thing to create the data, we can directly use the Spring code, and while using the Spring and Spring Boot code, we need to use the Hibernate, and then we will be able to enter the data, right? But if we are going to use the Spring Boot way, then it's going to take a lot of time. The first thing. The another thing that we can say do is directly insert the data in any of the tables. Let's say we selected the products table, and then ID, name, description, price, created and modified it. This is the thing, right? So what we can do, okay, let me show you something else from first. So if I want to see something, I want to print from 1 to 10 or 1 to 5, I can do it in the Java program, right? To print 1, 2, 3, 4, 5, right?
Yeah.
How can we do this in database?
Writing functions.
Come again?
Writing functions.
Okay, we need to write function, right? All
Yeah.
right. Then there is, I mean, like for the for loop, we have something like the for loop, right? In Java or in any other languages for looping purpose. So similarly, this thing is way too common, right? Looping thing. Every language provides this thing for the end user to use. So similarly over here as well, we have something. We don't have to write. We just do from and then generate underscore series. Then I'll say okay 1 to 10. So I'll get the data 1 to 10, right?
Okay.
So this is looping, right? It looped 10 times, right? So the same concept of the looping, if I can add it while creation of data, then it becomes powerful while creating the data. Then we don't have to write the entire, okay, let's need to check the products table first. Okay, now we can write the data. We need to insert the data into this table, right? We need a lot of data. So let's see first, okay, without index, alright. So insert into and then public dot products. Okay, And then what we need to do, we need to mention that which data we need to enter. ID, name, description, price, create, date, and modified date.
Values.
Come again?
Values.
No, we are not entering the values right now. Values
Okay.
will be, we want values to be generated by its own. There are
Okay.
two ways in which we have inserted the data. One way in which we have mentioned that okay, which column we need to use, and in the way
Okay.
we directly use values so that the default ordering system will be used. Right now I'm using this because I'm about to use the generate sequence for this, right?
Okay.
So over here what I can do, like the first thing, okay, okay, wait, okay, let's just copy paste it, and I need to check how many data is there already. Orders, okay, products, okay, only 5 data is there, right? So this is the query that I was creating, and then I will do say that okay, select, I need ID, right? So I'll say select GSS ID. Okay, you will get to know what's happening, because in the earlier query that I have shown you, I selected GS from the generate sequence, right? So it was given me 1. So whenever I'll do, but the thing is, if I'll try to start with the 1, then there will be an primary key unique constraint issue, right? So that's why I will do it in the later on. Instead of from 1, I will start from 6, because till 5 I already have the data, right? So in generate series I will provide 5. Okay, then what I'll do, so the ID is sorted. Now I need name, right? So for the name, what I can do, I can just say that okay, for this thing I can just add and then append something. Cool. So what we'll do, we have already seen this is product, right? Product. Okay, I will do this thing and product. Okay, wait. Yes, product, and then concatenate underscore, then concatenate and GS. Product underscore and concatenate with GS underscore product underscore and then GS. What will be the GS? The value 1 2 3 4 5, right? So product underscore value will be there, and I want it as name, right? So the name is sorted. Now I want product description, so the same thing I can take product underscore description underscore and concatenate with GS as a description. I could have left it also, but no issues now. So let's price. Okay, let's do 100 plus GS as the price, right? And what's left, created date, so it will be now as created date. Okay, and now as modified date. Okay, so this is the data that I want to insert. Now I want to make sure how the looping should go on, right? So from where I need to take this data, from generate series, and I will start from 5, 6, because till 5 I already have the data, right? Otherwise the product ID I'm taking at GS, right? So the value I will put here, it will be treated as GS. So I want to enter from 6 to 10,000. Okay, my bad, as GS. Inserted 9995 rows, right? So now if I try to check the rows, then it will be way too last, right? So instead of going through all this, let's just do select count as strip from public dollars. Oh my god, products. So now we have 10,000 rows, right? 5 was there and the rest we have already created. So now what we are going to do, we are going to create a little more rows. So instead of, we have now till 10,000, 1 instance, 100,000, 10,000, and let's make it a lakh, at least one more zero, right? Okay, 10,000 is the issue. 10,001 I need to make sure it's 10,001. Then okay, 1,000, it's 1,000. 10,001. Okay. Once 10, 100, 1,000, 10,000 lakh. Okay, my bad. So once 10, 100, 1,000, 10,000 lakh. So instead of remove 1 0, and now 90,000 motors has been inserted. Cool. Then select count and then asterisk from public products. Cool. Now we have a lakh, almost a lakh product. So now we'll do select asterisk from public. Now you will see the difference. Products to where id equals to acha, id equals to 100. It's completely cool, but we'll do the explain analysis. Okay, and instead of doing this, let's try to find select asterisk from public product where price equals to 25,000. Okay, this is the product, but I want to know how it's searching it, right? Explain analyze. So SQL scanning is being done, right? And how much time it's taking? 139 milliseconds, right? Less than a millisecond, 0.139 milliseconds is the planning
That
time,
is-
and execution time is 223 milliseconds, right? Almost 24 milliseconds. But it will be a combination of these both, right? Because planning is also part of the time that is going to take. So almost 24 milliseconds, completely little over 24 milliseconds is there, right? So this value keeps on changing whenever we change the data. 23.968 170, right? It will never be same. Even if we run the same query also, it will keep on changing, right? From 23 to 26 right now. But it will vary in the range. It will not vary in the seconds. It will vary in the milliseconds range. Okay. So right now it's doing the linear scanning and then taking 28 seconds, right? So we have seen till far that 23 to 28 seconds is taking right now, right? So what we can do for this scenario, there are different indexes that we can use. And why do we use indexes? We use indexes just to make sure that we find data in a better way, right? And how it is done, like a book has an index, right, at the very front. If I want to go to the chapter 4, it will tell me that okay, page number 994 is the place where you will get the chapter 4. Instead of going through all the pages from the start and going to the 994, I don't have to read 994 data, right? I can directly go to the 994 page because I have an index created in the very starting of the book, right? So that's what it will happen with this also. To find this, see, rows removed by filter was 9,999. It has to read the entire book if you take the example. So it has to read the entire data, right, just to find this answer. So rows filtered was 999. So the total time that has been taken 28 milliseconds, almost 29 milliseconds. So it is the time it requires, or the database requires, to verify or sequentially scan 1 lakh rows, right? But we don't want it. We want it to be fast because it's only 1 lakh records, right? So it should be fast. It should be way less time, right? Not this much. So in the last session already we have seen, right, how to find triggers, how to find indexes. So in this table there is no index that we can see directly that we haven't created an index on this table. But we can create, now we will create the index directly. And how can we create index?
Create index.
This is the most easiest. Let's first check the product table, and in the indexes part we have only primary key index, right? Nothing else. So I want to add the index on the pricing. So the same thing, easiest thing in the world is database for the developers. Create index, right? Then index name. Create table name. Create table, then table name. Create view name. Create trigger name. Create function name. So same goes with index. Create index and then index name, like product price index. Cool. Then where I need to create the index, right? on a table, right? Which table? Public products, right?
Okay.
And then if I try to give the column name and then products table, but I want to use it on price, right? On table. Okay, table we don't need to write on name. Okay. So while I was saying table name, I have written table also. So now if I try to search this, now we have two indexes, right? Earlier the range was, if I try to find the data, earlier it was doing the linear scanning and the time taken was almost 23, the range was 23 to 28 milliseconds, right? Now if we try to enter it, so it is using index scan, right? And the time from 23 to 28 milliseconds has been down to 667 milliseconds, right? Not a single millisecond. So this is the difference when we use the index and if we don't use the index. Okay. The first thing, the query becomes way too fast, right? It's almost 10, 20, 30 times faster now. Just using the index, simple index, right?
Okay.
So this is the one thing, and you haven't seen that there are different data structures that we use for this indexing, right? Index. Right now, if you see in the products table, we haven't provided any structure, right, to be used, but we get a BTree, right?
Okay.
So the default type of index is BTree. Over here also we haven't provided anything, right? Then also it is BTree. Now the thing is, how fast does it make? Right now we can see that it has made our search query faster almost 30 times, 30 or 40 times, right? Because if you multiply 600 milliseconds, I mean 0.600 milliseconds into the 23 milliseconds, then it will be almost 40 times, right? With the same timings, we can now handle the 40 queries within 23 milliseconds. So 40 times it has become faster, but what does the data structure says? If our data structure and algo is good, and then it is way too easy, right? BTree is written, right? So if we know how much data or how much time complexities BTree usually takes, then we are able to understand it directly, right? But if you are not aware, then the BTree takes log n time, right? And what does it mean by
Yeah,
log n?
login.
So again, it's a part of data structure and algo. So log n means if there were eight queries, 8 data, then I have to compare only 3 times, right? If there were 1024 data, then I have to compare only 10 times, right?
10 times.
So this is how, I mean, drastically it will change. For almost a crore, you have to do comparison. For almost 100 crore data, you have to do comparison only for 100 times max. So this is how it makes our query way faster. So that's why BTree is used, because if we have a billions or millions of data as well, then also it's good, because if we have a 1 billion data as well, then too for a crore, if there are 100 comparisons, then for a billion, then we need to just multiply it by 100, right? It would be 10,000.
Yeah.
And our system is able to compute a lakh query in a second, right? So a lakh operations it can do, like the comparison part, but
Okay.
more than a lakh it can do. Even our system is also able to, is capable of doing that. The servers that we use in the production environment, they can even process 10,000 to 1 crore or 10 million processes in a single second. So even if we have a billion database, a database with a billion records, then too it's easy for us to fetch the data within a certain time constraint, within 30, 50 or 80 milliseconds of time, or maximum 100 or 200 milliseconds of time, we will get the data. But the thing is, we will do some extra things as well. If our data is so large, we will do the sharding, and there are different other concepts as well in place by which we can make our system faster. We are not going to dive deep into that, but we have seen one thing, that okay, if we try to use the index, if we want to make the system faster in the database, then one thing that we need to go for, very first thing, is indexes, right? Now alright, so the thing is, we have seen the default type of the index in the databases BTree, right? But then there must be, if something is default, then there must be something else as well, right? There must be some other types of indexes as well, and we need to know which type of index is there and how we will create it, right? So the another type of index is hash index, right? Hashing again is a computation part. We solve the question using hashing, right? That too.
Okay.
Alright, so we are not going to dive deep into those things, but
Yeah.
I will just let you know few things. Okay, so one is BTree, we have seen, right? It is the default type. Time complexity will become of BTree, that will be the login, right? The other one will be hash. Okay,
Okay.
we will go sequence by sequence, and we're not going to create every column because hash is little different. We have to create another column and then we have to do the steps. We're not going to do that. We are just going to cover it by the theory. Cool. So this is the first thing, the BTree. BTree is the default one. If you don't give anything, then it will be the index that will be created by the database will be BTree, and it's not in the default method only. I mean, it's not like in the Postgres only, it's using the BTree. If you use some other as well, if you use some other database like Postgres as well, then it will be the BTree, right? It's same
Okay.
across every database, especially the RDMS, right? So the next index will be the hash index. And why hash index we used? I mean, you know the time complexity of hashing. If you want to get some data from
Hashing.
hash,
Yeah. Order of one. Yeah.
yes. So it's same in the hashing is same in the Java as well, right?
Yeah.
So hash table is the underlying data structure. So what we do in hashing, why we use the hashing? In hashing, if we have multiple IDs, like let's say product table, I want to create. I mean, product we already have an ID, right? But let's suppose, okay, this is not a case where we use this thing because product already having ID. Let's suppose there is a setting. A student can come and he wants to apply for a setting. I mean, he wants to he wants to give a test, online test, right? He wants to do an online test. So, and he wants to complete his test under a certain criteria. Like for example, is audio proctoring on, right? Is audio proctoring on? That means is his test being monitored by AI for audio? Then is video recording on? Video recording on, right? So is video saving? Then is video proctoring on? Okay, proctoring on. So it will be third thing. Is navigation allowed? Navigation allowed during the online test means that you can browse some different application or you can use some different tabs also, right? Allowed. So there will be multiple things. So there can be 10 and 20 of these settings, right? And if I want to make sure that I want to get student who has already who has completed test during the audio, in which the audio proctoring was on, video proctoring was on, and navigation was not allowed, and let's say something else, let's say disconnection allowed, max disconnection allowed, max disconnection allowed, that it can be 5, it can be a numeric, right? 5, 10, 20. So maximum disconnection allowed should be 5, right? I want to find a particular user who has, or users who has given test in this particular scenario. Then the first thing I need to do, I need to create a composite index, right? I need to create an index with multiple columns being used, right? First thing will be this. But the thing is, in this particular scenario which I am trying to explain to you, in this there will be multiple, not only 5, but it can be 20 columns, right? On which I want to find the data. Then it won't make sense to create an index on composite index, to create a composite index that too on 20 columns. Then
Okay.
this thing does not make sense. So what I can do is, instead of doing this, I can make an index out of this. Hash I can create of all the data it has, right? So there can be a value of, there will be an index which takes, if there is a value true, false. Okay, I need to go from here. So if this is true, this is true. So it will create a hash. The index, the new index, that hash index I'm trying to create, it's going to create a hash out of this, data and
Acha.
we'll save it also. We can save it. Then there will be a hash column as well. Hash column as well will be created. And then when I try to find search a query where this true, everything is true, then it will create the hash of those things and then find with the hash that we have created over here. With this query, again our system becomes faster, right? And the total output will be on O1, right? And this will be on login, right? But still, this is O1, but still the login is preferred, right? Okay, big O login. Still login is preferred because this is only for a certain cases, right? BTree I can use. We are going to dive deep into BTree later on as well. Because BTree we can use, this thing we cannot use in the sorting, right? The hashing we cannot use in the sorting. Or even for range. Only if one value I want to find only one value, then only I can use it, right? Because a hash range I cannot put. Is it making sense to you?
Okay. I mean, you if these values that you are hashing are true, there is more, high chance like many students will be having true. So all hashes they will collect. No chance.
Collision.
Yeah, I mean, so many columns will have same value. True. These values you will take hash, right?
See, the thing is when what you are saying is true. When a lot of values are same, then the hash will be same, right? But
Yeah.
isn't it what we want?
Acha, okay. How many students based on the nature of query you are saying? Okay. How many students? Yeah.
Okay,
Okay, got it. Yeah.
okay.
Yeah.
So we want to find the data, right? It's not a Java question
Yeah.
where we need to tackle the collisions.
Okay.
We are trying to find something, right?
Okay.
All right. So this is the second thing that we are using hash, but hash is not suitable for the sorting, right? Because we need to pass some data,
Yeah.
and then based on that data only the matching values will be there, right? So there is no concept of help, no concept that we are going to get the help from the hashing in case of whenever we want to do the sorting as well, right? So this hash will be only used when you want to get a matching data on one-to-one basis, right?
Okay.
Okay, just give me 1 second, I'm getting a call. All right, cool. Where were we? Okay, we are going through this. All right, so we have seen two indexes right now, right? BTree and the hash, right? Then there are different indexes as well. Like one is gin or gist. It's called gin or gist. Why this is used? I will let you know that if I try to create an index on the products table, select, okay, there are a lot of rows now from public products, limit 5, okay, limit 5, cool. So name, right? We have a name. So if I'll do select asterisk from public products and then where name equals to lipstick, right? So right now if I try to see how it's working, then it's using sequential scan, right? Because there is no index. If I create index name BTree index on public orders using, okay, public orders, and over here I can directly enter name, right? Name does not exist. Okay, okay, products, table name is products, right? Index is created, right? Now earlier it was searching the lipstick, right, using sequential scan. Now
Yeah.
if I search it again, now it's using the index, right? It's become way faster. But what if instead of complete search I want to do the partial search where name I like, right? And then I want to, okay, my bad, I want to search with the lips only, or lip. Sequential scan it's doing, right? Now
Okay.
the query is same. It just instead of equals to operator, I have moved it. Alright. So based on this, we know that okay, if we try to use the I like, it's not going to work with the index, right? BTree index what we have created. So
Okay.
but the thing is, for the partial search also, I want at least for few cases I want my query to be faster, right?
Yeah. Okay.
So the B tree will work in almost all the cases, but B tree will not work with the string tables, string column when we use the I like. With the normal equals to operator, it will work,
Okay.
but not with the I like.
Yeah. Okay.
So what are the other indexes? We need to know the other indexes, right? We need to know the other
Okay.
indexes that we can use instead of B tree, right? So now comes the GIN or GIST index. So why do we use it? Is used for partial search, right? We already see that it will be used for the partial index, right? Partial search. Hello,
Yeah. Yeah.
because our partial search was not working on.
It was not working with BTrees.
Yes. So for B tree it's not working. That's why we have to use now other indexes. And now
Yeah.
what we are going to do? We are going to try to use the GIN index, right?
Sure.
So let's drop the index again. Very easy. Okay, let's first need to know the name of the index. So D product. Okay. Let's do one more thing. We can try to create an index again on the same table. So you will know that is it possible to create the index or not, right? So gin. But the thing with the gin is sometimes we need to add an extension as well. But right now it's completely cool. We'll create index and the index name. Let's say name, and then name index gin or just we can use, and then on public products, right? Earlier we were directly using the name, right? Now
Hmm.
we will use on the public orders using
Gin.
gin and then the name. Now there is an error, right? So what should be the correct query?
Yeah.
We haven't seen, right? Using we need to use first thing, right? And then it's saying that gin is not there, right? You must specify the operator for class. Data type error. No default operator for access method gin, right?
Okay.
So what does it's trying to tell us? It's trying to take gin as
Acha, Jin as a fixed character it wants. Huh?
no.
I think name is Varchar. It is varying character length.
Come again?
Name was Varchar of type.
Name was
It was its data type was varchar, variable character.
okay. Then
Jin might be expecting fixed length characters.
no. This okay. Using data type character varying is no default operator for class method for accessing gin. Okay. So what what you are saying? You are saying that okay, the product is the products. You are saying that it's variable carrying. The name is var carrying variable
Yeah.
That's why it's not working, right?
Yeah.
No.
Guessing. Yeah.
No. Try to find some other answer.
So name already some one index is there, I think. Yeah.
Come again.
Two indexes can be there on same column.
Okay. Okay. That's what you were trying to do earlier. Come again.
And one index already exists on that name column. X.
Hello.
Yeah.
So you are saying that over here, because we have used gin the second data, so if I use description instead of that, then it will work, right? See, are you aware of vectors?
No, no.
Okay. All right. The thing here is, when I try to use the gin index, right? Full text search whenever I need to do the on the varchar, and I need to create a gin, then I need to use a vector. That's why it is giving me an error. And one thing that you can see over here, the thing that we can get from here, that no access method, right? It's saying the method, it's using gin as a method, right? And it's saying the data type char varying has no default operator. It has no method to work on it directly.
Okay.
So gin and gist, there are two different indexes that works on the partial search only, right?
Okay.
So if I want to use this gin, then I need to create the vector first, right?
Cha.
And but in our cases, we will not create another item, right, directly, because if you want to use something, we don't want anything to be used directly. So instead of this, if I try to use, instead of gin, because vector you are not aware, we are not going to cover that right now. So if I just try to do with the gist and name, then again I'm getting the same error, right? Same error, right?
Yeah, yeah.
So generalize inverted tree, that's what gist and gin is. But the thing
Okay.
is,
Okay.
if I'm trying to use it directly, then I need to, if I used to use directly, there are two ways. One thing is that I can alter my table products, right, and add a column, and then say it as some anything. I can say it, right. It's vector and it's in description and then vector, and the type will be, let's say, ts and vector. Alter table products, add column, and it has been added, right? And if I change it with ts vector, column ts vector, okay, I have
Description underscore vector.
b on products, public products, using just ts vector. Ts vector spelling is also correct.
No, no, it's a
Okay.
type you said, no? TS vector is a type. Description underscore vector is the column name.
Oh, my bad. Yes, sorry. Description underscore vector. Okay, cool. So now the index has been created, right?
Okay.
This is the one way. But the second way, if you want to use it, what you can do, if I need to check the product table. But the thing is, over here this vector has been created, right? TS vector type. But still I want to use this thing, right? Description I want to use directly. Then there are extensions that needs to be activated.
Okay.
But are you saying something?
No.
But there might be a chance your company won't allow you to use the extensions. There are PG extension, Postgres extensions are available for different purposes.
Okay.
So the gist and gin, if you want to use, then it comes with an issue, right? That the data types need to be same, and it keeps on updating depending on the version of the Postgres.
Sure.
Okay. All right. Now the other index is BRIN. Now the other index is BRIN, and why we use BRIN? BRIN is for blocks range. Now the thing is, let's see how the first thing. Let's see how the BTree index works. BTree index will work, create an index file for its own, right? Like the first page of the book, which we call index.
Okay. Okay. Yeah.
So the thing is, whenever we create this index file, the index that we create using the BTree, it creates the data in this order, right?
Okay.
Let's say that we have only 5 data, so it's going to create the data in this order.
Okay.
Okay, just so what happens? That is it good for? Are you seeing anything good for sorting over here?
It is already sorted.
Okay, this is okay. Wait. See, this is not ID, right? Let's say we ordered something by price, so it will be like 50, 100, 100. It is sorted, but this is index file. This is not the data, right? This is index file.
Yeah. Yeah. Separate column. Exactly. Yeah.
So this is index file. This is not index file. This is the data, right? So let's say this is the total data that we have, and I want to order the data, order by price, right? This is the price index or price, index file for price, right? So if I want to get the products order by price, right? So the ascending order is there, right? I don't have to order by, I have all the data already sorted, right? So I can directly use the index, right? And
Acha, okay. Already sorted data. Range you can pick up. Yeah.
so the
You
thing
are
is,
saying that.
if I want to find something, order by
Yeah.
ID descending, right? Order by ID descending, limit 5.
Yeah.
So I don't need to sort the data, it's already sorted. I'll just need to provide this 5 rows, right?
Yeah.
Then what becomes, then what's beneficial if I try to do this is that what's beneficial, whenever I create an index on a particular file and that index is a BTree, then my sorting order will also be taken care by the index, right? It won't work with other indexes, right? But the thing is, the index file will be greater because for every price there is a value, right? So the number of data I have will be the number of records in my index file, right? But what happens with the BRIN, with this hash, it's not going to happen, right? Because with hash we are going to make some, I mean, try to find some values, create some hash out of some group of values of already created existing columns, and then try to find a hash and then try to match it, right? First thing. Another thing, with the gin and gist, it gin and gist creates it's a data structure, again, generalized inverted tree. So it's complete, it's try to do the partial matching and then moves along with it. And over here the BRIN, what BRIN do, BRIN is used in cases where I want to search for the ranges. Like example, I want to find a product between 100 to 150, right? So what it's going to do, it's going to make a mapping of, it's going to make a range of 1 to 10. So if I take the prices of 1 to 10, then it will have this data. Okay, 1 to 10 price, and then I will have some product IDs 1, 7, 8, 9, and 19. Right?
Acha.
So over here, the product
Hmm.
from okay 220 to 50. So now what happens over here? I have data for every price, right? Every entry I have some data. Over here I have some ranges. So the size of the index file is less, right?
Hmm.
And what happens with this? It becomes a little easier for the insert queries, but it's not as fast as the BTree, right? Because still I have to find in I mean, if I want to find some order with price 150, so okay 2 to 50, right? So 2 to, let's say it's 80 to 80 to 200, then I need to 80 to, yeah, 100, then I need to find data in this, right, in entire this area. So it will BRIN will provide you a range where you are going
Okay.
to, where you will go and then do this linear searching. But what's
Okay.
beneficial with this is it's very light, because it don't have to uh, save the entire data, right? And why it's used? It's used for the ranges, right? In Amazon, or in any, it's not in Swiggy, but in Amazon and other e-commerce platform, we have the range, right?
Yeah, yeah.
That we can. I want something like, for example, I want some mic with price starting from 5,000 and ending at 15,000.
Yeah.
So these things are better. If I try to use the BRIN index, then these things are better.
Acha.
So in conclusion, if I want to use, these are the indexes. There are different types of more indexes as well. But the thing is, in most of our cases, we end up using only BTree. I have used all these four. But the thing is, it depends on your
Very.
requirement, where
Yeah.
you want to use it, right?
Yeah.
Then there is BitMap index as well. There is one more index,
Yeah, yeah.
BitMap.
Correct.
Have you heard of BitMap index?
Yeah, hard work.
Tell me something about BitMap index.
Hmm. This, I've heard but don't know. Heap bitmap. Bitmap.
Come again?
Heap bitmap. Heap bitmap scan. While explaining queries, I read somewhere. Heap bitmap scan.
Okay, okay, leave it then. See, this BRIN is block range, right?
Yeah.
This BRIN is block range. The thing that I have just explained, it works with the block, right? So the block range index is BRIN. So then IN, I mean, the definition comes with this only. The IN will be the index. So we'll take B, you will take a range, and then IN of the index, then it will make bin, right? So now the question is bitmap, right? So bitmap, usually if you see the bit, then from just seeing the bit, we can say, okay, it will work very fast, right? O1 will be the time complexity, because bitwise operations are also very fast, right? Because it's closer to the system to work on the bitwise manipulation, right? So bitmap
Okay.
index, when we need to use, I mean, like the BRIN has a specific reason, right? When to use, when
Okay.
we have, when we want some block ranges, right? Gen just also, we want, when we want to use, the I like or the partial search over the string, right? Hash, we have some constraints, right? We can only use when we want to create
Equal.
some hash out of some existing data in our system, and then based on that we want to find something, then we can use the hash index. And
Yeah.
then BTree is largely acceptable, because it can directly be used, right? And it helps in many other operation as well, like in sorting. So that's why BTree can be used with the 99% of the cases. But with bitmap is useful only in cases where we have low cardinality. Are you aware of cardinality?
Cardinality is the measure of uniqueness in the column. Low cardinality means more repeatable data is there.
Yes. And how we use it in the system? We create enum in our Java, right? Because we are not going to, cardinality is not be in the system right now. I mean, we'll pass it using the enums in our Java class, right? Because we are working in ORM in real life examples. So in enum, for example, we have candidate states. Like, what will be the candidate state? It can be test not started, right? Then it can
Okay.
be finished if he finished the test,
Yeah.
and it can be aborted, and it can be disconnected, right? It can be paused, right? Or it can
Running.
be, I mean, this is enough, I guess.
Active.
Okay, okay, active, yes. Running, we can say the test is running. Then these are the states, right? The states is not going to be a lot. So
Yeah.
whenever we have some index, if we want to create some index based on some cardinality, low cardinality, right? We don't want uniqueness. We don't, if you don't have a lot of uniqueness, like this is the example that I have provided, right? Where we have used, but it can be male, female, right? Male, it can
Yeah.
be female, and other genders like third gender and bisexuals and all those things. If
Acha.
we have some limited cardinality of a certain column, then we can
Yeah.
go with the bitmap index. It is only beneficial with this scenario only, right? Like for the
Acha.
genders, yes or no flags, or any other number, any other columns with less number of distinct values. Only there it is efficient. Otherwise, it's not efficient. So it creates a bitmap. Bitmap again is a structure, data structure that we use, and then that particular bitmap is used to evolve everything. We are not going to, like, we have not dived deep into the BTree and its structures. We are not going to dive deep into the bitmap. But right now we know, right, what are the use cases of each one of these indexes, right? So in most of
Okay.
the cases, you are going to end up using BTree only. Why? The reason is we usually tend to use only numeric and string data, right? And numeric and
Okay.
string data can be handled by BTree. Only in few cases where we want the partial search, you need to go with this, right? Otherwise, you need to open the extension as well. Otherwise, this hash, this BRIN, and this bitmap, it's very rarely used. Bitmap is like I haven't created on my own, but I have seen it being used. Right? But I didn't see why I mean, its index was not required because we were not using it, right, very openly or very frequently. So even if we did not use it, over engineering thing I have seen it, right? Because we didn't had to use the bitmap index because for no reason we are dealing our insert or update queries. So that's it from this. And the thing we can see in the earlier sessions also, I have seen that told that okay, if you want to find the indexes that we have, so we can go over here, right? But then you will
Yeah.
say that there are a lot of indexes, but I only want to, let's, if we try to see the index, then there will be a lot of indexes, 126 indexes. Then you will say okay, no, I want to know the index from, okay, uh, I want to know the index of only my table, right?
Hmm.
So what you can say that okay, cool, no issues. Or from publish table where table name equals to and products. So these are the indexes, right? And
Okay.
how these indexes has been created.
Okay.
See, visible?
Yeah.
Cool. So we have seen only, till now we have seen indexes, normal single indexes we have seen, right? Public orders, okay, products we have, okay, products, where limit 5. Cool. So this is the 5 data that I have asked, and we know that where id, let's use where id equals to random id, let's say 25,000, right? And if I try to find how it's doing this thing, then it's doing the index search, right? But what if I'll say where id equals 25,000 and name equals to lipstick? Okay, my bad. Then how, what it's doing, it's now I have index on id as well. Oh, my bad, it will always use the primary key, right? So see, the primary key, products p key, it's using primary key. I want to change it with the price. Cool. So right now it's using the price index, right? And then filtering out the rows, right? But if I try to use where price equals 25,000 and lipstick should be the name, but if
You will reverse.
Okay, yeah, I can reverse it, but I was thinking of something different. Okay, you are saying to change the sequence, right? Reverse
Yeah,
the.
reverse, if you do reverse auto-alignment.
Okay. You will learn something new now. So where I mean it's already we have already covered it. Although this planning, this planning, why do this planning part? Because he thinks that the user is a fool. He don't know which one to use. It's not like if you try to write lipstick first, then it's going to use the lipstick index, right? It does not go with this
Yeah.
way. It will try to find which which index will be better for me, right? That's that's how it's going to use it. Not on not on your test case, right? That whether you want it or not, right?
Yeah,
Uh,
okay.
let's do the production. That's why this planning is right. Otherwise, we just need to execute it. Let's say we have index on description? No, we don't have index on description, right? So great. So instead of name, let's take it description. Again, it will be fast, but okay, because this thing is there, so it's using this. So let me create another index and create index, and let's name it price description index 2, and now on public products and public products, over here I will say price and description, then using BTree. Okay, so now I have taken two indexes, right? Two columns.
Sure.
This is called composite index. So over here, product price, okay, no description, see, price description index, right? So it is providing us the data that on two columns it is there, right? So it is composite index.
Okay.
So now if I try to run the query again, still it's going to use this only, right? During the course of the planning, because it will be faster, because I am trying to find something with the ID only, right? And that ID is a unique item, because I've created our data in such a way that it becomes unique. That's why it's always going to use product price index, right? Not the product description index. But what if I drop this drop index index name? Now if I try to run this, now it is using this thing, right? Price description index, visible.
Yeah.
And see the timing that it took, 161.161 millisecond, right? And over here 1.365, right?
Yeah.
So the better was to use the product price index, right? So that's why during the planning phase it concluded that it's better for the system to use the product price index, right?
Okay.
Sometimes the seniors or the people think that okay, if I do the description lipstick over here and there, then it will use that. It does not work in this way. There might be a chance that the query planning takes less time. This thing can happen, but execution will never be. Execution time will always be same, right? And it's going to check which way will be the best to execute this particular query, because you don't have the data, right? It has data. It can even convert your subquery into the joins and your joins into the subquery as well. So it all happens in the planning phase. Cool. So now we have seen the different types of indexes. We have created the data. We have seen the time complexities. We have seen which index to use. Composite index we have already seen. So by this we will conclude our database session.